Okay, and let's make sure that we are live. Okay, and let's make sure that we are live. Okay, so አምስት ደቂቃ ይቀረናል የዳይፎር እስኪከፈት። የዛሬው it has to be less than 2 hours. I have work to do. It has to be less than 2 hours. ከሁለት ሰዓት በላይ ከፈጀብን I'm gonna cheat. ማራይቻ just reload this. Oh, we have one viewer here because I closed it, I guess. Yeah, if it takes us more than 12 hours and more than 2 hours, ከሁለት ሰዓት በላይ ከፈጀብን I'm gonna just cheat or maybe just not do the day4. የምንጠቀመውን ላንጉጅ ደግሞ አልወሰንኩም፣ ግን ከትላንትናው ዲባክል በኋላ I think I should just use Rust today to gain back speed. ግን የትላንትናው ሶሉሽንን ከኮሉ በኋላ ሳይሆን ከስትሪሙ በኋላ I think I improved it. So if we go to source part to Idris, so now we have this find max function. So the other function was just too complex. It started doing a bunch of stuff it didn't need to do. First of all, I added a type here. I added a record type here called battery bank, and it has a single field called power, and that's what we're using to represent each number instead of using natural numbers everywhere. Just having a separate type helped a lot. We implemented show for it here so that we can print it, and then also created a battery banks type, which is a list of a battery bank, which should be the battery banks, and our final input is a list of battery banks. So the input is also here, and then I started with using those types, and then so we have this find max function. So basically this is what does it for us. So what it does is you give it a suffix, the amount of suffix that should be that's needed. That's the least amount of number of digits that should be left to the right side of the number, and then it goes over the list and then finds the max. But it does that only looking at the numbers that would have some amount of suffix to the right of them. So you first to get the first digit, we call it with 11. So we want the first largest number that has at least 11 open positions to the right of it, and then 10 open positions, and then 9 open positions. And then meanwhile, every single time we do this, we also need to return the position of a new list of digits that only contains the number that are after the maximum number we just got, because we can't go back. It has to be, the digits always have to go from left to right. We can't just go back and get another maximum value, otherwise it would end up just being 999 or something like that. So it also returns a bunks. So this one is being called by the previous one's bunks. So all of them are being called by the previous call's result. So and then we get all of those 12 digits, and then we have these combined digits we created yesterday, and so basically just goes over each number and multiplies them by 10 to the power of their index, and then sums them up, and then that just combines all of the digits into a single number. And then we have this find solution function. So it just calls find max battery bank on each one of those battery banks, each one of the the inputs we have, and then this is working. Yeah, and then we have 1 minute. I don't know what language we're gonna use. Probably Rust. Yeah, we're gonna probably use Rust. Okay, let me. Actually, until then, why don't we just run this, and so if we can do build part2.package, and then build exec part2. So this returns this number, which is supposed to be my. So yeah, this is the final result. So yeah, just refactored it a little bit to have it look a little bit nicer. And then let's check out the leaderboards. I guess leaderboard. Let's check it out. Okay. So there are 7 people at least that did. 8 people, I guess. 8 people that did የሶስተኛውን ቀን ቻሌንጅ okay እዚህ ጋር አንድ ሰው አለ I guess. I think some of the most of the people just did part 1 and didn't do part 2. That's why the gray circles. Oh, not most people, but yeah, most people either didn't do it or only did part 1. Yeah, that's expected, I guess. And yesterday's one was, you gotta think about specifically your the puzzle we are given. You know, ትላንትና combinations ምናምን ብዬ when I was thinking of tricking the system. That's why we got messed up. Okay, so let's just go back here and then maybe increase the font a little bit, and then let's start reading the today's challenge. You ride the escalator down to the printing department. They are clearly getting ready for Christmas. They have lots of large rolls of paper. Large rolls of paper everywhere. And there's even a massive printer in the corner to handle the really big print jobs. Okay? Decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole base while the elevators are offline. Actually, maybe we can help with that. One of the elves replies when you ask for help. We are pretty sure there is a cafeteria on the other side of the back wall. If we could break through the walls, you would be able to keep moving. It's too bad all of our forklifts are so busy moving those big rolls of paper around. If you can optimize the work the forklifts are doing, maybe they would have time to spare to break through the wall. Okay. The rolls of paper are arranged on a large grid. The elves even have a helpful diagram, your puzzle input, indicating where everything is located. It's gonna be a grid problem, and then we gotta find the paths around it or something like that. I think that's gonna be annoying. The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. If you can figure out which rolls of paper the forklifts can access. Okay, the forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. So there is one at the top, second, left, right. So አራት አለ 5 6 7 8. So all we need to look for all the 8 adjacent corners around. Okay. If there are fewer than if you can figure out which rolls of paper the forklifts can access, they will spend less time looking and more time breaking down the wall to the cafeteria. In this example, there are 13 rolls of paper that can be accessed by forklift marked as X. So in this example, there are 13 loads. Okay, okay. I think this is relatively easy. Consider your complete diagram of the paper roll location. How many rolls of paper can be accessed by a forklift? So this is I think gonna be relatively easy. Let's create the O4 here, and then maybe before we do that, let's going to flick the next. We have We don't have a Flake. Let's install. I guess I don't know the line, but let me just check it from. I'm gonna install Rust Flake.next. Let's get Rust Analyzer and the Rust compiler. Going to Flake. No, come on. I don't copy it properly. Let's go down here. Bum, 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 bum. No. Okay, now we have it. And then let's wait for that to install. Okay, I just finished installing. Perfect. And then there's also another thing we need to do because of. No, I didn't think we need to do that, right? Okay, I don't think we might not do that. Okay, so let's go into day 04, and then let's create cargo new part 1, or should we just cargo init here and then have different source? I'm just gonna do this. We've been following this pattern, so I'm gonna go into part 1, cargo run, and then going to main.rs, and then cargo run. This work. It should. Yep, it's working correctly. Hello. Okay. So what we need to do is let's create or make the inputs, and then inputs example dot text. This is our input, which is gonna be this. Save that, and then let content is gonna be standard fs read to string, and then inputs. Let's just do this. Inputs example dot text unwrap, and then debug contents. Let's do that. And cargo run again. Yep, beautiful. So now what we need to do is let's create and we're gonna showcase like idiomatic Rust as we're solving this. So let's create a struct called grid. So a grid, what does a grid have? So it has a position. No, it has sales, I guess. Yeah, so yeah, it has sales. And let's call this sales. There is it has a vec of sales, right? And then what's a sale? A sale is an enum. It's either we need to know about its location, but its location can be easily determined by its index in this list, and then width, and so it needs a width and a height. And this is the grid, right? We always have a static width and and a height. So, and then an enum, a sale is an enum, right? It's an enum of a per role or empty, right? It's this, and then we can implement parse for from star, I think, from star for sale, right? And then we can implement missing members, and then we can match on the S here, and then do this, and then maybe I need to install actually I haven't used me8 yet. Okay, and then missing. Okay, so and then we have two positions. We have two. So if we get a dot, it's gonna be self dot colon colon empty, And if we get a if we get an @ symbol, it's gonna be a self the paper row. And then if we don't get anything, it's gonna be some kind of error. But that's why we just installed the Mi8. So Mi8 is one of those. So there are a bunch of I don't know what to call them. There are like error libraries in Rust that help you manage your errors, so you don't have to do unwrap everywhere. And Mi8 is one of those cool ones that have a bunch of colors and stuff. So I can do cargo add Mi8 fancy, and then the logging would be nicer when we get errors, right? So it's just I'm gonna use this, and then we can use Mi8 result instead of using the default built-in result. So this will allow us to do something like this. So I can do something like this, Mi8 result, right? And then it will return a unit type, not used, but, and then on our main function we need to install it, I think. Custom. I think we need to install it, I think, right? Where it is, where main function, we need a main function. Is there an install or install it? I guess it doesn't, we don't need to do any decorations. Okay. And then okay, and then tuple, and then here we can just do a question mark instead. Cargo use result, and then yeah, question mark, cargo B. Oh, okay, this is confusing it. Let me just do that, not do that. And then okay, it's saying the required IO error diagnostic because of that rate diagnostic is not implemented for. Okay, I guess we're not gonna be using Mi8 today then. Let's look at their GitHub repository. I can only return Mi8 is fully compatible with libraries, blah blah blah. In application code, into diagnostic, okay. Into diagnostic, okay. But what is the error type for Mi8? I can do something like this, Mi8 error, and then in this case we can say okay, and then in this case we can say Mi8 I hope they have no ensure, no, not ensure, something that returns an error. How can I create an error? Okay. I don't want to create error objects, I just want to use a string. And then most of them have like some kind of macro. So let's go into the macros, and then there is a bail, return early with an error. Yep. So we can say bail and say no sale, unknown sale, unknown sale. Okay, yep, that's correct. Okay, so we just did a slight detour to set up Meet. So okay, so now we can parse the actual sales, but now we need to parse the grid, and that will be implemented here. Impl from star for grid, and then implement all the missing members. This is gonna be a meet error, and in here, so we're gonna say L sales is equals to s dot lines dots, so lines dot, yeah, well, of course lines don't split, right? No, lines dot map, and then each one is a line here, and then for each line we want to split, we want to get the cars, right? And then for each car, yep, and then we need to map, and then we have a car char, or let's call this x, which is a char. But okay, so we messed up, so this needs to be something like, and it can't be a from star, right? It needs to be a, we messed up here, and then let's just do impl sale, because we have to parse a from car instead, and then let's do car, and then this should be characters instead. And then this is still meet. And then here we need to call, this should be flat map, and then sale from car of x, and then we can call okay here to turn it into a result. Let's save this and go back. Okay, so we have a list of cars now, and then we can flatten them, right? We can flatten the iterators to have a single iterator of all the, so it's gonna be 0 1 2 3, and then right, and then it's gonna be collect into a vec surrounding brackets turbofish, the turbofish syntax. Okay, so we have the sales now, but we also, how can we, I think maybe I need to store the line here, and then get the, to be able to know the width and the height. So I think I need to do, let's keep the lines here, s dot lines, before we do anything to it. So width is gonna be lines dot, lines at 0 dot count, but you can't index, I cannot index into, So it's gonna be something like lines dot, it's an iterator, but is there a way for me to get the first value? Can I get the, show me how to get the first value? I don't think there is, right? I have to iterate over it. That's what it is. There is a way for me to call next, but uh, next, but we can just make this peekable. So I can make this peekable. I don't like doing this, but yeah, we can just peek into the first no peekable. So, and then I can do peek or next peek. Yeah, it has a peek function. So why didn't, so when I do peek here, oh no, there is it. I was just spelling it wrong. So, and then we can do a peek, and then here we can say this can be an unwrap actually, or else, right? Okay, or okay, or and then the error is gonna be me8 dot bail, and then it's gonna be couldn't find first line, right? And then this should be papa, and then this should be a parse usize, and then this will also bubble up, and then we can do into diagnostic here. Okay, we have the width, and then the height is gonna be simpler than that. Height is just gonna be lines dot count, right? And then we can finally create the object here, self, and then we can use lines here, and then we can use self sales width height, and then wrap all of that in an okay. And then we're getting an error here because it should be mute. And then let's do cargo. What is it talking about? If this is, which is being used? Okay, now let's do grid, which is a grid is equals to contents dot parse into diagnostic, and then I guess we don't need to do into diagnostic because that's already a me8 error. And then we can do debug grid, and then it's going to here it's going to grid derive debug, and then let's go down there, derive debug. Let's do cargo. Oh, couldn't find first line. Let's debug the contents first. Let's do that here. before we pass it in. Okay, this is not what we want, I think. Okay, or 0. This has to be something like okay or no, okay or else. That's why I needed to. Yeah, okay, and then we can do some error or okay, there is no input here, no input here, and then we can do into diagnostic, I guess. Let's comment out this line and then yes. When I try to and then let's do cargo or these the produces a result in variable result which is incompatible with result grid. Okay, wow, okay. In that case this should be okay or else. What's happening here is Bale returns an error object, a full-on error object. What we want to do is return something. It's not that. Okay, so let's just do this, I guess. It can just be a string, and then there is a diagnostic for this. No, there is not. We can just, I don't know, let's just do this unwrap. I don't care about that. And then here it's complaining about the, okay, count consumes it. And then I guess in that case we can just do s dot lines here, and then we can say mute, and then let's not do the pickable stuff here, and then we can say dot next instead on the lines, but this means we have to change it to mutable, and then that consumes it. Let's go cargo run. Invalid digit found in string. Oh, digit. Oh, so this has to be next. We don't have to. We're not gonna parse that, but we're gonna say dot map dot map. So this will give us a line. What we want is the length of this thing, not parse it into line dot length. And then we're not gonna parse it, and then we can just unwrap. Right, this is what we wanted. Cargo run. Nice. Okay, so we have a width of 10 and a height of 9. So yep, 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's correct. So okay, so the next thing we need to do is be able to index into this grid. So we need an impl grid, right? And then we need to be able to get the value of a cell at a given position. So it's gonna be get add index, which is gonna be a usize fn, or it can be something like, should we use two numbers, or we can say get adjacent, or yeah, get adjacent. So it's gonna be, this is gonna be a week of sales, or a week of option of sales, right? Some of them could be empty. So let's do a week of option of sale, and then the counter could count them however they want to count them. So let's do at the given index. So it's gonna be at the given index. So what we're gonna have to do is we're gonna keep track of two values. So for the grid is gonna be a 3x3 grid, and it starts at, let's say it starts at if they give us index, let's do this. Let's diagram this. We can do a manual, like get each one of them, but if we want to do a loop, it's gonna be something like, let's create a guest document. Let's delete, or how can I delete all of them or select all of them? I think there is no way for me to select all of them. I have to click the delete button. Nope, sorry, let's don't care about that then. Okay, so what's gonna be is, we have them on the grid binor ziga. So ziga, like if there's like one x here, so what we're gonna need to do is, this is at index. This is at the index. So like the current position that the get adjacent function was called at, right? So we're gonna need to do a loop where this one is gonna be, so let's don't care about that actually. Let's don't care about that. Let's care about this. So the one we actually care about is gonna be at this at the top left corner. So this think of this as our 0 point, and then what we're going to do is just do a nested loop. And then let's connect that. Connect. They don't want to connect. This one can connect to that one, I guess. And then let's create another one here. Then okay. So yeah, so in order to get all of these numbers, we can manually hard code them actually. I don't know if we should do that. Actually, that's clearer. I was gonna do a loop. So this is gonna be, I guess, let's manually hard code them. So this is gonna be index. Let's handle the first one. So this is gonna be index plus 1, and then this is gonna be so this is gonna be index minus width, right? The top one is gonna be index minus width, and then the bottom one is gonna be index plus width. And then this one is gonna be index minus 1 minus width, and then this is gonna be index plus 1 minus width, and then this will be index plus minus 1 plus width, and then this will be index plus 1 because, and then it's gonna be plus width. I think this is how the grid is gonna be laid out. So we can say, I guess let's do it. We're not gonna use a for loop then, I guess. To top left, it's gonna be self dot sales. No, we don't have self here. Self dot sales dot get at the index minus 1. Okay, so this we need to use something like an i32, or let's do an i64 because the input might be larger here, right? So we don't have to mess around with we can yeah, we have to check if this is minus. Okay, so I think what I need to do is something like this: function get, because we need to be able to access them with and then index with i64, and then this will return an option of a sale, and then here we need to match, or we need to call index and then return self dot sales dot get as index as i64. You can't convert an i64 into, right? You can't convert an i64 to a usize. I don't think you can. Yeah, slice indices are of type usize or ranges of usize. Cannot be indexed by, and then what if we call this as usize? It will fail, I think. What does that mean though? Like, what about when it's 0? What about when it's minus 1? I think let's just do a index equals to index dot try into, and then let's call this try into a usize, and then if dot okay, and then no. Okay, I remove the unnecessary generic. Okay. Yeah, so if it's not if it's less than 0, or if it's or if it's a or if it's a negative number, we just return 0 early, right? And then I think we can just do we can just implement clone copy on the cell, because we don't care about that. That's just a number, and then we don't have to do a reference here. Yeah, or yes, copied, we can call copied on it. And then here, instead of using the native, they can call dogget. Yep, put there. Okay, so let's go back to our chart here. So it's gonna be -1 minus width. It's gonna be -1 minus width. And then of course we need to do self width is equals to self dot width as I64. And then let's do the same for the height. Oh, we didn't actually use the height in any of this. Wow, it's interesting. Okay, so let's do that. It's gonna be a top left. That's gonna call this top middle. Then it's gonna be width instead. Top middle is index minus width. And then top right is index +1 minus width. Then boom. And then let's copy that. It's gonna be middle left. It's gonna be index -1 middle. It's gonna be self index, and then +1, which is right. We could have used the loop of 0 to 1 and then maybe something like that, but I don't know. Okay, bottom left. It's gonna be index minus plus width. And then bottom middle, it's gonna be index plus width. And then bottom right is gonna be index +1 plus width. And then we can convert this into a vec of the left, of middle, right, middle, left, middle, right, bottom, left, okay. So now what we need to do is, okay, what is asking us to do? Are we supposed to sum all the positions? So count them. 13 rolls of paper that can be accessed by a forklift. So how many rolls of paper can be accessed? So if they have, so what we need to do is yeah, I think what we need to do is, so let's say let's actually call it here. So what we need to do is we need a way to call a function for every index, right? And then what we need to do is I'm gonna call this roll count, which is gonna be grid dot sales dot map itar, and then we can say enumerate or should we do a for loop here? I'm not sure. So enumerate and then map. This could be this isn't actually, this isn't supposed to be a grid over here, so this should be an iterator over 0 till self grid dot width times grid dot height, right? This is the range we're going to be using, and then we can call into iterator on this one, and then we can call map, and then for each one we're going to, for each index we're going to call grid dot get adjacent of start index as a I64, right? And then here, let's just save that. And what we need to do is in here map over each one, and then filter them by x, where x is sum and is sum, and the cell is, let's add a impl cell here, and then say func is paper, and say it's gonna take a self, and then let's do that, match over the self, and then this is gonna be true, it's gonna be false, and then this is gonna be a bool. It's sum and C is paper. So, and then we can say after you filter them, count them, count. Oh. Where's this is count. Okay, and then we have a roll count, which is gonna be, yeah, and then they say if count, so this is gonna be actually, and then they say filter x where x is equals to 4. Where x is equal to 4, and then we need to count that, right, which are exactly 4, and then count that, and then debug roll count. This is gonna be all in one go, but let's just do this. Okay, it's saying 7, which is incorrect, right? 13 rolls of paper that can be accessed by a forklift. So how does the adjacent counting work? Let's do this. Let's not count them, but log them, right? And so we can know which specific number indexes they are. Roll count, instead of, let's collect them into a vec. Okay, but we need their indexes, right? If let's do the filter here, and then let's say equals 4, and then do the collect there, and cargo run. Okay, it's at index 1, 2, 3, 4, 5, 6. All of them have 4. How does this logic work? we want to make sure. Oh, is sum in Daralem? Is sum? If it's none, we also need to count it. So this is x dot is none, or right. I think that's it. Because for some of them, like for the ones at the top row, it's gonna return a let's do adjacent, and then let's see what we get for grid dot get adjacent at index 0, and then debug adjacent. Yeah, it's gonna be okay. So at bottom at this one, so all of the top ones are gonna be none, right? So top middle, top left, all of them are gonna be none, and then but I know what's going wrong. We need to know if we can't iterate over each position. We need to iterate over each paper sale, right? So we need to have something like this. So function is paper at, and then it's gonna take the self and then index in an I64 again. I guess this could be a U size, and then we can say self dot sales dot get at index, and then we can say map over them, and then we can say the sale is paper. This is paper, and then this will return a bool. So we should be iterating over filter, and then index only if that index has paper. So grid that is paper at index. Unwrap or default. Okay, so roll count is now empty, but I think so 4 empty spaces is gonna be x. So we need an empty here. Check here. It's gonna be is empty, and then it's gonna be false. We could have just inverted the is paper, but I don't know. This is clearer. So let's do is none or is sum and is empty, right? Nice, I think this is correct. So instead here, let's do count. Run 10. What? So and then it's 13. What are the positions we're missing? Okay, 7. This is 0, 7, 8, 9. Or maybe it's an issue with our indexing logic. Let's go back here. So index minus 1 minus width, top left, index minus width, or let's make sure that's correct with this one, with the first element. So this is the top three are none, and then the middle left is also none. Middle we know what it is, it's our position, it's empty. And then middle right is gonna be empty again. And then yeah, some okay, so below us it's also, oh, it's not empty, right? There is a below middle. How is below middle implemented? Index plus width. Oh, isn't index plus width, wouldn't that be correct? Right, so if we are at index 0 here, 0 plus 10, we're looking at this one actually. So okay, all of the widths have to be width plus 1, I think. We're looking at the wrong element. So now it's 12. There is one thing. Okay, let's double check this again. Okay, none, that's correct. Left is none. Middle left is none. Middle is empty. Middle right is empty. And then middle left is a paper roll. No, that's not correct. Middle left, no, bottom left is none. This should be a none. So bottom left. So bottom left is gonna be, according to our chart, it's gonna be index minus 1, but plus the plus, wait, am I not? Maybe somebody's called the mistake. No, nobody's called the mistake. Okay, so it has to be right. I think I'm correct. Or I guess for the it's inverted, since it's inverted. Yeah, we are at index. Oh, maybe the order of operations actually makes always it should be performed. So let's make sure the other ones are correct. So yeah, okay, so bottom left should be none, but it's saying it's a paper roll. And then let's look at bottom right, bottom middle, which is correct, it's a paper roll. Bottom right is also paper roll. And then I think I'm gonna do this. I'm gonna log this and I'm gonna debug this. Cargo run. Now and then let's disable this for now. What should this number be? It's index minus, so we are at 0. Zero minus 1 is gonna be minus 1. Minus 1 plus 11 is gonna be 10, right? We need a way to check when our, yeah, so it's not gonna work like that. I thought it would be, it will give us a number outside of the range, but it won't. So we need to extract out the row count and the width, the row count and the column, row and column, and then we need to maybe update how we do our maths using that. I actually, what I want is for that to return I expected that to return a -1. So if it's 0 minus 1, So I think we need to operate with rows and columns. We need to do that. This fancy stuff is not gonna work. So let's extract out the row, the current row. So the current row is gonna be index divided by the width, right? So if we are at for example, let's say 10, 11, if we're at the 11th position in this list, right? If it's gonna be 11 divided by 10, that means we're at the first row. So index divided by width, that's our row. And then we need a rows, we have our rows, and then we need our column. So it's gonna be our column. No, actually, this is gonna be, yeah, is it gonna be divided by our width, or is it gonna be divided? Yeah, I think it is. So if we are like, let's say it's at index 22 نكفل 10 بانتجر كونه ሁለት ይሆናል. So we're at the second row, and then column, let's say row and column, and then I think is this gonna be, so is this gonna be index divided by 8? Not sure, but we don't need to do the plus one here. To do the plus one here is gonna be 8. Let's debug this out. Row, col. And then to make sure that's correct, let's go back down here and comment this cargo run. Yeah, okay. So 0 0 0 0 what 0 0 0 0. Their column should be their row plus their current position in that, which is the remainder we would have gotten. So it's gonna be something like index modulo width yeah. Okay, so we have the row and column, and then we need a new gate function that's gonna operate via yeah, so it's gonna take a row and column. It's gonna do the same thing for the row and for the column. It's gonna be row times column, or row times width plus column. And then here it needs to be, so the row minus 1 plus no, so top left row minus 1 and also column minus 1, and then this one is gonna be row minus 1 but at the same column. and then this one is gonna be row -1, but at the next column, and then it's gonna be row at the same row, column -1, and then this is gonna be at the same row at the same column, and then this is gonna be at the current row, column +1, and then this is gonna be at the next row, and then the previous column, and then this is gonna be exactly at the current row, column, but row +1, and then column, and then this one is gonna be row +1, and then column +1. I think this should be correct. We're doing a bunch of modulos and stuff. Do we have the debug in there still? Okay, now it has to be correct, otherwise 14. We're off by 1. But this one is actually looking correct, so let's see which one of them are the numbers, and then let's call like this instead, into a vec. Let's see which ones are we counting. So if it's 10 by 9, this is 90 elements, 90, and then this is this 88, 89? No, this is 88 is this one. This is supposed to be, I think, right? That's not 88. That's 89, I think. Oh, yeah, 0 to 89. So that's 88. Okay, that's correct. This is 0 to 89 because there are 90 elements in this, and then their positions are 0 to then 7. Maybe we need to get the columns and for these values. Let me do a map here, or I guess for each. Nope. I'm gonna do a for each and say let's get the index, and then I'm gonna print out the row and column. Let's do that. Self.width, then print ln. No, not self, but grid.width, grid.height. Come on, these are supposed to be simple. Just row, comma, column. Okay, 0,7. 1, 2, 3, 4, 5, 6, 7. But all of these are supposed to be, we should have gotten at least, and then 2,8. 1, 2. And then that's it, I guess. 0, 1, 2. 0, 1, 2, 3, 4, 5, 6. It's not index, but the index position 6. This is completely wrong, I guess. And then it's 3, 0, 1. Oh no, I guess, okay. So this is 3, 7. So 0, 1, 2, 3, 4, 5, 6. But it's saying it's 3, 7. And then the 2, this has to be, I would have expected this to be on the second row. On the row, there should have been 1, 1 comma 1 comma 0. Our filtering is wrong. So okay, so an empty position, an empty eight adjacent positions. If you can't figure out which rows of paper for Chris Canada, they will spend less time looking and more time breaking down the words. Okay, a valid position is either a none because we didn't find any sale there, and if we did find some sale there, it has to be an empty sale. And an empty sale is an empty sale. Okay, yep, that's correct. Eight comma 16, that's completely wrong, right? Or I think this our match is wrong. So yeah, no, it's ask. I think so. Given an index into a 2 by 2 array, how can we determine the row and column? I should have been using a 2 by 2 vec from the start. Given no, I guess not a 2 by 2, but okay. So row is integer division, index over the row. Oh, so there is no row plus. Why did I do that? There is no row plus stuff. It's just the module. Okay, I'll go. And then bottom there. Okay. And then here too. I'll go. It's still the same thing, but at least now we can, let's see, this should be like 0. I should see at least 0, 2, 3 and then stuff like that, but it jumps over to 0, 7. For an n by m grid. N is the number of rows, M is the number of columns. I think this is correct. Maybe this is the thing that's messing us up. Is paper art, how is that calculated? So let's do that can't be it, right? This is going from the 0 to the, I guess we can do, I don't know, that's the same thing. It's the same thing. This should be going from, do I have to make this inclusive on one side? That can be, that's not it. So let's just do, let's see what is paper art is returning, right? So at least let's make sure that we're filtering out all the correct position that where there are papers. So 0, 2, 0, 3, 0, 5, 4, 5, 6, and then 0 7 0 8. No, it should be, yeah, and then 0 8, and then there's nothing there. So the next one is what, at 1 0, and then the last one is at 8 8. Yeah, so it's at 8 8. This is correct. And then let's see this is adjacent at the current index. We extract the row and the column, then row minus 1, column minus 1. Should we just be doing I think we have to do that though. If either one of them ends up being negative, we need to be able to return an n. I don't know what the bug is, to be honest, in this one. Maybe it's how we're counting them. So let's just do let's get the adjacent ones and then just log them or something like that. Let's see the adjacent one for one of those for one of the positions that we expect to be valid but it's not being valid. So this is 0, 0, 1. So the 0, 2. So it's at index 2. So let's see what the adjacents of number 2 look like. So yeah, so all the top rows are none. On the left side it's empty. On the right side it's a paper roll. On its bottom, so these are the middle columns. So on the left it's empty, on the right it's a paper roll, and then it itself is a paper roll. And then on the bottom, oh no, okay, I know what's wrong. We're not excluding the shit, that's a stupid mistake. Middle shouldn't be part of this, right? It will mess up our count. We should just be returning the neighbors, not the, because this seems correct. So bottom right is empty. Yeah, this is correct. I think that what was messing us up is, and then let's do 4. Let's do Agora. Isn't that what was messing us up? No, it's not. Come on, why is this? So exactly 4 empty positions. So these are exactly 4. Oh, bottom right is empty. How is adjacents counted? Are we only supposed to look at the 8 adjacent positions? So they mean all of them. So we are looking at all of them, but for this one, fewer than 4 if there are fewer. So it's not exactly, it's like, it's greater than or equal to 4. Okay, count, and then let's do cargo 20. I don't know what the logic is. If there are fewer than 4, is this less than or equal to 10? What we should be counting is the paper rolls, not the empty spots. Is sum and is paper, and then if there are less than those, it's still 20. We're filtering out the middle. 8, but these are not 8, right? So 1 2 3 6 7 8. So yeah, we were returning 9 elements previously. And then let's run this again. Then let's undo. No, let's redo that. But let's say that this should be greater than or equal to 56. We need to know if there are fewer than 4 rolls of paper in the 8 cells around it. Let's see why this one was allowed. So it has 1, 2, which is less than or equal to 4, or less than 4, and then now it's 9. I don't get it. Our indexing is correct. We know our indexing is correct. So this, if there are fewer than we've been going, we've already done and just again. I don't know what's going on. The grid counting logic is kind of being messed up. It's a simple puzzle, like I don't know why it's, maybe I should just use that's not where the bug is coming from. So they said get the adjacent 8 values from the list ውስጥ እነዚህ እያንዳንዱ ፖዚሽን 8ቱን adjacent ሴሎች እዩና ከዛ እነዛ ሴሎች ውስጥ if there are fewer than 4 rolls of paper around it, so count them up, and if it's less than 4, that's a paper roll they can access, so count that. That's what they're saying. But and then my adjacent list የሚያደርገው function ትክክል ነው if I'm not. So if I'm checking it for this one. So if it's at the bottom, so the top there is nothing. Bottom left there is an empty cell. And then if it's on the right of it, there is a paper. On the bottom 3 are paper roll, and then empty. So this is like 1, 2, 3 paper rolls around it. So this is obviously less than less than 4. But if we call for each on this x and say let's get the row in column, and then print line row comma column cargo r, let's call this index, this is grid.width, and if we run this, okay, we get the file. Okay, it is being counted now, but we're not counting enough. So 0, 2, 0, 3, 0, 5, 2, 3, 4, 0, 5, 0, 6, and 0, 8. These are like correct, and then the next one is at 1, 1, 0, and then the next one is at 2, 6, 2, 6, and then the next one is at 4, 0, 1, 2, 3, 4, 4, 0. But what about 4, 9? It didn't 4 9s, right? No. So this is what's the position of this in our list. It's at the 0, 1, 2, 3, 4. It's at the 4th one, so it's gonna be 4 times 10, 40, 49. No. So we have, according to our input, we have, then it is the 9th element, maybe. So 0, 1, 2, 3, 4, 49. I think 49 is correct. So let's do 49. Why isn't that being counted? Let's look at what that returns. Cargo run. Okay, at the top of it, okay, so top right, these are the top. So top left, paper roll, that's correct. Top middle, empty, that's correct. Top right, no. Okay, so for this one, top right returned a paper roll, which is incorrect. Let's go to our top right calculations. Okay. We need to check. Come on. It's so stupid. I think what we need to do is here, if column is greater than self dot width or greater than or equal to self dot width, return an else do this, or row is less than or equal to is greater than or equal to self dot height, right? I think that should be the case. Okay, and then let's get rid of middle here. No, it keeps. This is thing messed up. Cargo run. It was a simple puzzle. We just, and then let's count this. So let me just comment this out for now and do a count instead, and then debug log it. 11. We're just missing. Yeah, this character no number again. We're not getting there. So maybe I think if it's fewer than Slala, I think maybe less than or equal to. I don't know which it should be. Now it's 31. So fewer than Kala, it's less than. But let's see the Gami log Nargachona. Let's see which one is failing. So I think maybe this should be greater than maybe exactly a column. Now it's 9. Do you guys know? Should it be equal or greater than or equal to? Or so if the current column we're looking at is greater than or equal to self dot width, and then let's forget about this and let's do our own maths. So let's do this. This should be like it. So it should be 0 to self dot width, inclusive, I guess, right? And then includes or contains. How do you do this? Contains. Contains the row. But can we say it's inclusive on that end? No. How can we say it's inclusive? Maybe by doing that. If it does not contain, if it's not contained within that, the column is not contained within that, and then the row, if it's not contained within 0 to self dot height, contains paper row, return none. Okay. Right, and then let's go back here and then paste that in, comment this out. Fine. One zero 26 4049, and then 70, and then 81. What about 801 or 881? That's incorrect. It should be 80, right? So let's look at 80 then. 80 cargo run. So Samania, top left is none. Top, no, that's incorrect, right? And then I guess here let's look the index as well, so it will help us find out which one index equals carbon. Oh no, I guess index equals, and then pose equals something like this. So 81, this is 81, which is correct. But for ballistic, the other one, 70 is correct, because no 70 is not correct. 0 1 2 3 4 5 6 7 8 9. So I don't know why the 90s are not being considered, but this one is incorrect then. So we're missing exactly 1 2 3 4 5 6 7 8 9 10 11. We're missing two, or and then we have one incorrect one, and we're missing two, because all the other ones seem to be correct. 40, but it's weird. Why would the counting logic be correct for the other ones and then mess up when it gets down here? Because we are at so 9 is at the end of the, so I think my suspicion was correct. Maybe this one should be equals, the height is inclusive, cargo one. Yeah, we're still not getting them. In fact, I think we lost some. We lost 49, so I shouldn't be contained. Okay, let's go over this, and then for let's look at 81. How did we end up with it? Let's look at 81, because that's incorrect. Cargo run. So 81 is this element right here. So at the top left there is a paper roll, top middle it's empty, top right there is a paper roll, so that's the top row, and in the middle two, on the left side it's empty, on the right side there is a paper roll, and on the bottom it's not empty. Bottom left is bottom right, there is a value there, and then bottom middle is also there is a value there. So what happened here is we ended up with 8. That's our row number, and then so to get the bottom left we do +1, and then 9, So this will be row plus 1 will be 9, which is exactly self dot width. Right, but we're excluding it right there, and in column -1 will be 0. I don't know if we're excluding that. We might be. Okay, we fixed that bug, but what about the issue with 90 not being considered? 90 cargo run. Okay, top. Okay, so 90 is this one. Or let's consider it with this one. Top left is none. Top middle is empty. Top right is not none. Why top right be none? The values. So this one is incorrect. It should be paper row. So top right is row -1. Our current row is what is our current row? 90, so 9 -1, 8. Our current column is 8 plus 1, 81. So top right, this is it. So we got a none instead, because let's do this, I guess. So just do this. Late valid weights equals 0 greater than or equal to row, and row is less than self dot weights, and then valid height is equals to 0 less than or equal to 0 greater than or equal to row should be greater than or equal to 0. That's what I'm trying to say. And then row is greater than or equal to 0 row, and then row should be less than or equal to, in this case I guess, self dot height, or I guess it should be, I'm talking about column here. No, if I'm talking about this should be the column. I think this should be right. So the width should be between 0 and the width. The maximum it can be is 9. It's gonna go from 0 to 9. But the row, that should also just go from, right? That should also just go from, but we're using a modulo to calculate the. So okay, so if we are at 90, the width is 90. Kafel Nasser is gonna be 9, so that we're gonna be at the 9th row, so that should be equals, because the row is gonna be 1 based but the column is gonna be 0 based. It's kind of what's messing it up, I think, but yeah. So if it's not a valid height, or if it's not a valid width, otherwise do a as u size and as u size. It should be to fix it. It's not fixing it. I don't know. We're at 2 hours already and we can't even calculate the positions. I'm gonna let's just do the count for now. I think I'm way too down at this point. Counting grids. Gee, this should have been simpler. Part 2, we didn't even get to part 2. And we're already past 2 hours. I think already near part. Okay, top middle is empty, top right is paper roll. Yeah, this is correct. Bottom left is none, bottom right is empty, bottom left is none. This is correct. 90 is correct, but the count we're getting, let's see what count we're getting. It's 10. Then let's log them out. Which ones are we missing? Cargo run 70, so paper roll. So it's the logic, if there are fewer than 4 paper rolls, why isn't this one being included? That's less than 4, right? This should be our range stuff we did was messing things up. Okay, now it's correct. What the fuck? We spent an unreasonable amount of time on that. I'm disappointed. Fuck. Yeah, stupid. Let's remove that. What about, is there anything else we need to remove? Let's finally get our puzzle input after 2 hours of messing around. Ah, shit, stupid. Save. And then move move input that take us to the current inputs directory, and then let's go down here, see is empty, is not being used, and then boom, so down there and call input. Let's run this. Let's run that. 1533. Nice. 1 gold star. Part 2 is gonna be even more complex. Maybe I'll give it an extra 30 minutes. It's 152. If we can't solve it by the extra 30 minutes, I'm gonna be gone. Okay, now the elves just need help accessing as much of the paper as they can. Maybe before we do that, let's get into this. Let's go into git ignore git ignore target and inputs. Now I guess inputs have already been ignored by the global ignored. Oh yeah, so commit fit implement die 3 die 4 part 1. For this part 2, and then cargo build. Okay, now the elves just need help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Okay, once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklift might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the elves remove if they keep repeating this process? Starting with the same example as above, here is one way you could remove as many rolls of paper as possible. Using the highlighted to indicate that a roll of paper is about to be removed, and using X to indicate that a roll of paper was just removed. So if we remove 13 rolls of paper, these 13 rolls of paper, and then we'll have new positions left, and then we'll remove those 12 rolls, and then we can remove 7, and then we can remove 5, and then we can remove 2, 1, 1, then 1, and then 1. So step 1, once no more rolls of paper are accessible by a forklift. In this example, a total of 43 rolls of paper can be removed. Start with your original diagram. How many rolls of paper in total can be removed? I think maybe this could be this could be simple, because we just have to filter them out, and then we would replace them with empty positions at those places. So we will return a new cell and then keep over iterating over the same cell until, so it will be like a while loop. So I think maybe we can do, so we can move all of this stuff into the grid itself, and then we can ask it. So we can say, we can yeah, we copy over all of this, and then maybe it might be one of those trick questions where we spend a whole bunch of time looping because it takes a whole bunch of time. But we can say find removable paper rolls, and then it will take in a self, which will return a usize. Do that, copy over this, and then pop, and then so do that. That will be self instead. Here too it will be self, it will be count, and then here we will do a something like this. So this would be a mutable grid. So I think we should do, so the removable, this should just return, removable paper roll should return a vec of usizes of the indexes of those things that can be removed. And then here we can do a map. We can take out the index, forget about the sale, give me the index, collect it, right? And then we can create another function called so we can say function remove paper rolls, right? And then this will be a self, and then it will return hopefully a new grid. I think should return a new grid, or it could be like something like a comma. It should be an option of the an option of a usize. This will be the number of the count of the paper rolls we just removed, and then it will be a new grid, a new self that let's say grid, a new grid that represents that with all the paper rolls removed. So we can say let rolls is equals to self dot removable paper rolls, right? And then if rolls dot lane is equals to 0, we return a none, because we didn't find anything and there are no more rolls to filter out. If we did find something though, we can say let new sales is equals to self dot sales dot copied, or no, cloned, you can say iterator cloned, because we're gonna make a new one. I don't care, let's do an iterator and then we'll collect them, because that's it. So and then we can say filter the, and then I can say we can do an enumerate here, because we need the position. We can enumerate and then filter the ones with all the indexes where the remove what do you call it, rolls dot includes or contains the current index, right? So filter will only return if creates an iterator which uses a closure to determine if an element should be yielded. Given an element, the closure must return true or false. The returned iterator will yield only the elements that returned true. So we can say if they are not part of the role, return them. And then I want you to be collected like that into a vec, right? And then a vec. And then we can return here a roles dot lane, and then a grid or a self which has sales. Let's call this sales, which has sales, and a width and a height, which also come from self dot height and self dot width cargo run. Okay. What are the types? What are the errors we're getting? Now, of course, this should be a sum. And then cargo run. Of course, here we're missing a pop, and then a cargo run. Oh, okay, so this should be a map of, and then forget about the index, just get the sale and return the sale. That's actually wrong. So instead of doing a filter, we need to do a map, right? So if it is contained, we don't want to just remove it. If it's contained within the list, we need to make that cell a cell empty. Otherwise, it's the cell. Okay, at the bottom here, and then cell. This is the cell. Yeah, so we'll go over each list. If it's contained within the removable rolls of paper list, we return an empty, and then we just keep on going. Yep, that should be correct. So in here we can do a while. So let's see, count equals 0. This is also mutable, so we can say while let some count and removed, I guess, removed, comma grid is equals to grid dot remove paper rolls. You can say count plus equals removed and so let's say new grid, and then we can say grid equals new grid, and then finally we can debug count. So what is it that is asking us to return? A total of 43 rolls of paper can be removed. Okay, so it's just the count of that. Yeah, it's gonna take a while. Oh no, 9,206. That's how did we end up there? It's way too much. So okay, I don't even know where to start debugging this. 9,206. What the heck? this is the same as our example input, right? Yeah, so let's I wanna debug the roles dot length, or we can actually debug this here. Debug removed cargo run. This is there. We don't even have 9,200. It removed 1,533 elements in the first run. What am I returning? The sum accidentally? So remove map each index. What? In the first run, we're removing. We should be removing 13 here. Did we mess that up? So it's if we just did late roles is equals to grid dot removable paper rolls, and then the print line count is just to roles dot lane, because our previous solution was correct. The part one is all bargain, but I'll go. It's now returning something different. Wasn't it the exact same code we used the previous? What an idiot! You're not even using the example. Okay, now it's correct. Okay. Yep. Okay. Now let's do it. Now this is the actual run. Okay. Now it's correct. Now 43. Yep. Okay. Let's run this on our. Let's move that debug. Let's run it on our actual inputs. Okay, hopefully this is correct. Nice, it is correct. So 30 دقيقة قبل الفجر I guess no 7 دقيقة I guess. So we said we want to keep it under 2 hours. It's just 2 hours and 8 minutes. So yeah, we did it finally. Okay, we're like, I don't know, 30% of the way, or 33.333% of the way to the end. Yeah, we're lighting up. So basement ውስጥ ሄደን አሁን እነዚህ ፔፐር ሮሎቹ ናቸው I guess, and ይሄ diagram is actually talking about our movement. So we're going down the elevator and then talking to the different kind of elves and then adding a bunch of Christmas decorations. So finally we'll have it all light up at the end. Let's go to the leaderboard view. Yeah, so a bunch of people have finished solving it before me. Izzadin, yeah, a bunch of people. Yeah, so I think we just finished የዛሬው ቀላል ነበር. I just decided to use a one-dimensional array and messed up around this logic here, and then that spent a whole bunch of time. That took us a whole bunch of time, but yeah, today's was actually simple. Yeah, yesterday's was also simple. I was just messing around, but yeah. Okay, so that's it. Yep, let me just do this. Commit. Fit implement die 04 part 2 whimsy push, and then we need to go back to the readme and say dive or implemented in Rust, and then we can say rustlang.org. Yep, we've used the 4 different languages for the 4 different days till now. And hopefully for tomorrow, I don't know, I haven't decided. Maybe we'll do OCaml or something like that. I don't know. Yeah, we're probably gonna do OCaml. Yeah, so goodbye everybody. I'm gonna end the live stream now.